Hello everyone, welcome back. This is Jay. Today I will discuss on part 2 of the code, that is on earth pressure. In my first video, I discussed in brief about different parts of the code. So let's get started. I will discuss rudimentaries of certain terms used in soil engineering, which are relevant for this part of the code. First is angle of wall friction. This is the angle normal to the wall arising due to roughness of the wall's surface. Next is arching earth pressure. This is a condition where movement of top of the wall is restricted and there is movement only at the base. Earth pressure exerted in this condition is known as arching earth pressure. Moving on to three commonly encountered terms in geotechnical engineering. Active earth pressure is exerted on a wall when the wall moves sufficiently away from the backfill by either translatory motion or rotation. Earth pressure at rest is a condition where any form of movement is arrested. Passive earth resistance occurs when wall moves sufficiently towards the backfill. The figure on the right shows variation of all the three. Magnitude of passive earth resistance is maximum, followed by at-rest condition, and finally active earth pressure. Retaining wall is typically a long structure which holds back a soil mass. Next, moving on to symbols. The code presents about 33 different symbols which are used in different equations and figures. This is the next slide which shows the symbols continued. This is the last part of the symbols used. This slide shows the mathematical equation for active earth pressure as per Coulomb's theory. Basically, there are two earth pressure theories, one proposed by Coulomb and the other by Rankine. Coulomb was an 18th century French engineer. As per his theory, the soil shear resistance develops along the wall and failure plane. This method considers friction between wall and the backfill. So Rankine was a 19th century Scottish mechanical engineer. As per his theory, friction component between wall and backfill is absent. So between these two theories, Rankine theory gives higher coefficient values and is more conservative. However, this code, that is IS 4651, has adopted Coulomb's theory for earth pressure calculation. This slide is an extension of previous slide for a specific case in sight. The figure on the right shows a wall with pressure distribution for two different types of soil. The bunch of equations shown will help us in determining actual magnitude of pressure. Similar to active earth pressure, we have equations for passive earth resistance as developed by Coulomb. Again, for a two-layered backfill soil, these set of equations shown will help us in determining the pressure. The figure shown on right is a sheet pile wall with an anchor system. Now we are moving on to earth pressure coefficients for different conditions. The current slide displays K0 values for various types of sand and clay. This slide projects active earth pressure coefficient corresponding to different values of phi and delta. We can observe inverse relationship between Kv and phi delta values. The slide is an extension of the previous one. We have active earth pressure coefficients for both cohesive and mixed soils. The symbol Cw is wall adhesion. Now we are moving on to passive coefficients. The trend is one of direct relationship between K and phi delta values. Moving on to last slide. Again, this is a further extension of previous slide. Similar to active earth pressure coefficient, Kp values are presented for cohesive and mixed soils.